Cool, cool.
All right. Well, I had to push the record button because I did not have that set. But welcome everyone. My name's Jeff Martins. I am the Chief Operating Officer of Determinate Systems, and I'm going to be your host for today's webinar. Today, we are going to be focusing on FlakeHub Cache. Luke's going to tell us a bunch more about that, but FlakeHub is Determinate Systems SaaS product, and the cache is a core feature of it. So I'm excited to dive into that. And whether you are a longtime Nix user or just starting out, looking at how it might fit within your organization, I think you're in the right place. You're going to learn a lot, not just about FlakeHub as a product that we develop, but about the benefits of caching and why matters to you in general. So a little bit about Determinate Systems. We're dedicated to making Nix more simple, secure, and confident in the enterprise. We build tools like Determinate Nix. We have a recent updated announcement about that from a couple weeks ago. Of course, we are the company behind the Determinate Nix installer, the most popular and one of the most common ways of installing Nix. And of course, we're the developers of FlakeHub, the product we're going to talk about at today's webinar. We also contribute upstream and across the Nix ecosystem. We're lucky to count Okul Dolstra, the creator of Nix, as one of our co-founders. And most importantly, though, we are here to help organizations harness the full power of Nix, whether that's for software development, infrastructure management, or secure and reproducible builds. So that's a little bit about us. And now I want to intro the person leading today's session. This is somebody who spent a lot of time not just thinking about how Nix can be better in the enterprise, but actually making it better in work environments, whether that's a small business or a large company. And that's my colleague, Luke Perkins. So if you've been around the Nix community for a while, you've probably come across some of his work, whether it's some of the blog posts he writes for Determinate Systems, the talks he's given at different Nix conferences around the world, but also, PRs to open source projects upstream, as well as those that Determinate manages, as well as our proprietary products. He's one of the developers behind FlakeHub. And today he's going to cover, like I said, not just about getting up and running with FlakeHub Cache, but why you should be using a binary cache with Nix, and the best ways to do that securely. So before I hand it over to Luke to keep going, I just want to mention a couple things. We will have a Q&A at the end of the session, so feel free to drop your questions in the Q&A feature in Zoom as we go, and that way we can keep an eye on what people are asking and get prepared to answer them at the end. We'll do our best to cover all the questions, and if there's more than we can cover, we'll do what we can to follow up with you afterwards and send out more insights, whether that's directly or to the community. We've also enabled the chat feature, which we've talked about here. So if you want to send a chat, just make sure you selected the everyone for the to field. It defaults to panelists and hosts. And then finally, we're going to be sending out a recording of this webinar. So if you want to share it with colleagues or if you have to drop early, don't worry, we'll be able to send that out. You won't have to ask for it. It'll be part of the follow-up to this webinar. Okay, so with that, I think I'm going to stop talking and we're going to get into the exciting stuff. And I'm going to hand things over to Luke to dive into today's topic. So, Luke, go ahead and take it away for us.
Yeah, Jeff, can you hear me okay?
Yep, you're coming great.
Just checking. Thanks a lot, Jeff, for that great introduction. This is Luke here. I am coming at you from Buenos Aires, Argentina, the greatest city on the planet Earth. And I'm excited to see some of you present today and to talk to you about FlakeHub Cache. But before I get to FlakeHub Cache specifically, I want to talk a little bit about caching in Nix from a more high-level conceptual perspective, because I think it helps to set the stage for understanding how FlakeHub Cache is different from some other solutions. And I think that in turn will help to frame the discussion about how to use it. So no matter what use case you have for Nix, whether it's development environments or running NixOS systems or building packages, you are engaging in a process called realization. So note the British spelling here, so the S instead of the Z, which I'll adopt to be consistent with what you'll find in the official Nix docs and in the CLI output. So fundamentally, realization is when you turn a Nix data structure called a derivation into real bytes on disk. And a derivation is essentially a set of build instructions that Nix can run inside a sandbox environment. And when Nix realizes a derivation, it realizes the entire dependency tree for this derivation. And while it's doing that, anytime it runs into another derivation inside the tree, it realizes that too. So Nix is always thinking in terms of the full dependency graph, and that's a huge part of Nix's magic. So the full dependency graph isn't some accidental property or some special feature of Nix. It simply is Nix's ingrained worldview. So if you're realizing a derivation for a version of Git, for example, Nix has to realize the derivations for a lot of things inside the dependency tree. In this particular case, you've got bash in there, you've got a couple Perl things, gzip, curl, clang, LLVM, and some other like very obscure stuff that I don't quite understand myself. And those derivations, of course, have their own dependency trees that Nix in turn needs to realize. This all sounds a bit intimidating, but really it's not, because you'll notice here that I've been saying realize and not build. And that's because Nix has this incredible capability where when it's traversing this dependency tree, every time it sees a derivation, it can check to see if the result of that derivation is already in a known cache. If it's not in a known cache, then Nix needs to build it, which is less than ideal. Ideal, everything would be cached all the time, but of course the world isn't perfect. But if the result of that derivation is in the cache, if it's been pushed to the cache by some prior person or entity, then you can fetch those bytes, and that will almost always be faster than building. So in the case of Git from the example above, if Nix looks for Git in the cache and it's there, then it just pulls a tarball. And it doesn't need to realize anything else in the dependency tree because it already has the end result. And if that version of Git is part of a larger derivation, maybe another package that needs a pinned Git, then realizing that larger derivation is now faster and more efficient because you're just fetching Git. And if that larger derivation, let's say, if there's a larger derivation, let's say a whole NixOS system, and it needs that package that needed Git, then realizing that is now faster. So you can really see caching as kind of the lifeblood of Nix. And as I've said in the past, Nix without caching is basically a different tool, and one that I think would never have gained wide adoption because it would just be too slow. Instead, we have caching, and so we get this fantastic tool called Nix that unlocks all kinds of fun things. Now, the core mechanism behind caching in Nix is arguably store paths. So what Nix does during realization is it calculates a store path for every derivation before it does anything else. So an example for Git would be this fake store path that you see here. So Nix would look at the derivation just as a data structure. It would compute this store path, and then it would ask some cache or several caches, depending on your Nix configuration, if Git is already available, and the cache would say yes or no. And the store path would be the only thing that Nix needs to make that determination. And then Nix would just continue doing its thing over and over and over until there's no more work to do. So that's a kind of basic overview, but I hope I hope it helps to foreground things a little bit. So the general benefits of Nix, of caching in Nix, I think should be pretty clear just from my explanation in the last slide. Basically, with caching, everything in Nix just gets faster and more efficient. Using development environments gets faster because you build them faster. Building packages gets faster, which in turn makes development environments faster. Building NixOS systems gets faster because your packages are faster and all that good stuff. And some other fun use cases for Nix, like building Home Manager and Nix Darwin configurations, they benefit from caching as well for exactly the same reasons. And not only does everything get faster, say on your laptop or your workstation or your iPad or whatever, but it gets faster everywhere that Nix operates. So yes, doing Nixy things on your workstation gets faster, but your CI/CD pipelines get faster too. And if you're running, say, NixOS systems in production and you want to update those systems using NixOS rebuild, then those updates get faster. And more broadly, If you think about Nix as critical infrastructure inside your own organization, and I personally, I absolutely do, then your infrastructure is just plain qualitatively better across the board. What's a bit funny about the benefits of caching, though, is that they're so subtle that you start to notice them only when they're gone. And to me, there's a kind of beauty in that. So caching, it's this kind of fairy who floats around sprinkling fairy dust all over your entire stack. And after a while, you think that that's just the way things are and the way the world works, and that things are always that fast. But it turns out they're not. And you only realize it when you join a new organization that doesn't use Nix and everything is slow. As another quick bit of introduction, I want to talk about what I call the first generation of Nix caching solutions, just to kind of provide a bit of contrast with FlakeHub Cache and what our goals are for it. The first generation of caching solutions, and I'm not going to name names, but you might know, relied on a pretty simple form of authentication. That is, they use static public keys inside your Nix configuration. So if you wanted to access the cache at mycache.io, you'd need to copy a key that looks something like this into your Nix configuration. This approach is straightforward enough, but it presents all the usual challenges of having static credentials. You need to make sure that Nix is configured correctly on your developer workstations. You need to copy them into your CI environment. You need to worry about improper exposure, and you need to re-provide these credentials every time they change. It's not great from an ergonomic standpoint. It's not great from a security standpoint. And this is especially true given that we now have much better paradigms at our disposal, which we'll talk about more in a bit. Another thing that characterizes first generation caching solutions is that they allow ad hoc push access. So developers on their workstations can pull things from the cache, which is great, of course, but they can also build something with Nix and then run a push command that sends it up into the cache. And that makes push access decentralized in a way that we think is really undesirable from a security perspective. So someone on your team copies and pastes a command into a shell script and runs it, and now you have something in your cache that you might not want, especially if that cache is public. We think of FlakeHub Cache as the next generation of caching in Nix because it directly addresses some of the problems in the first generation solutions. So first, FlakeHub Cache introduces a brand new authentication concept to replace static keys. First, FlakeHub Cache supports federated authentication for a handful of major platforms with support for a handful of others on the way. For user login, we support both GitHub and Microsoft Entra, and we're considering some others. So let us know if there's a login option that would serve you better than these ones do. For CI/CD, FlakeHub Cache supports both GitHub and GitLab, although GitLab support remains experimental. So when you're pushing to the cache in CI, you don't need to provide any static credentials. You don't need to copy and paste anything. We get all the information we need from the platform to authenticate the process that you're running on. We also support authentication on AWS by STS, their security token service. So if you're running things on AWS, you get authentication with FlakeHub Cache for free, essentially. For systems that aren't major platforms like developer workstations, we offer token-based authentication. And this is a major improvement over static public keys because you can specify an expiration date for the key, and you can also generate as many keys as you need to for as many machines as you need to. So what are these tokens? For both federated authentication and for token-based authentication, this is all powered by JSON Web Tokens, or JWTs, or JOTs, as apparently you're supposed to pronounce that, which is kind of funny to me. The beauty of JOTs is that they aren't just valid or invalid, but when they are valid, they actually carry information of any granularity that's required for the problem at hand, which means you can do much more sophisticated things with them, like checking which GitHub repo the key is for, which AWS service the key is for, and so on. And that unlocks a much more powerful model for us. Oops. In terms of access control, FlakeHub Cache follows what we call the trusted platform model. And that's where no ad hoc push access whatsoever is allowed for FlakeHub Cache. So you can't accidentally copy a command into a bash script. You can't have a fresh employee on their first day accidentally push something. If you want to push to FlakeHub Cache, it has to be from a trusted platform as part of the CI run, period. So now that we've covered some background, we can move on to actually using FlakeHub Cache. So the first thing you need to do is install Determinate Nix. And this is essentially Determinate Systems downstream distribution of Nix, plus some extra goodies that we include to make Nix run a lot more smoothly in a variety of environments. One of the advantages of Determinate Nix is that it's hardwired to work seamlessly with FlakeHub Cache. So the fun stuff I talked about before about easy authentication and all of that is made possible by our Nix distribution. In terms of installation, you can install it on macOS with our graphical installer. You can install it on Linux in your terminal. And if you're a NixOS user, we have a NixOS module that you can use that makes that very simple. I won't cover installation here, but if you want some comprehensive guides on that, there are two places to go. If you're using Nix as an individual, we have a getting started guide for you at this URL. So docs.determinate systems /getting started /individuals. If you want to onboard your organization to it, there's a dedicated guide for that, same URL, but just swapping out organizations for individuals. Next, you do need to sign up for a FlakeHub paid plan, as FlakeHub Cache is a paid feature. You can go to flakehub.com/sign up to do that, and that page will walk you through all the organization onboarding steps. For individuals, it's $7 a month, but that gets you FlakeHub Cache and private flakes and lots of other fun stuff down the road that we're working on at the moment. For teams, it's $20 per user per month, but we're actually providing a promo code right now if you want to sign up, and that code is up and running, just all as one word. This code applies to both individuals and teams, and it gets you 1 free month of a FlakeHub paid plan. It's valid only today, so if you want to use that, do it as soon as possible. We're making it available only today because we're going to be publishing a recording, and we wanted to give you all, as attendees, something special, and we didn't want people to be able to watch the recording and use a promo code. So pretty simple. Once you sign up for a paid plan, you need to log into FlakeHub on your workstation. Using Determinate NixD, which comes with Determinate Nix, you can run Determinate NixD auth login token, and that will provide a URL that you can click to generate a token, which you can then copy paste into your terminal. It's a really nice model. Oops, what's happening in the chat? There we go. Just making sure there weren't any issues. And at any time you can check your authentication status by running Determinate NixD status, which tells you not just whether or not your system is recognized, but also which FlakeHub organizations you're known to be a part of. Okay, cool. So you're set up and ready to go, but there's nothing actually in your cache yet. So how do you actually push things? Well, remember from before that FlakeHub Cache follows a trusted platform model, so you can't just push things from your workstation. Instead, you need to push from a supported platform. Right now, we have strong official support for GitHub Actions, plus experimental support for GitLab, and we intend to support some others down the road, and we're actually working on one right now just this week that should be interesting for some folks. To make pushing as simple as possible in Actions, we built FlakeHub Cache Action. And this action does two important things. So first, it handles setup and authentication for you without needing to handle any static credentials or copy paste anything into your environment or secrets or anything like that. And then it does something really fun and kind of magical, which is that it automatically caches anything you build with Nix in your workflow when you've added this action. So you don't need to install a separate CLI tool or anything like that. If you Nix build something inside your run, FlakeHub Cache Action knows about it and just does the right thing, does the thing that you would expect. So let's see what this looks like in practice in an example workflow. So here you see a few things. So first, notice the permissions block, which is necessary to use FlakeHub Cache. So the ID token write enables the action to get the JSON web token for your repo, and contents read allows the action to read the contents of the repo. Pretty simple stuff here. Then there's a standard get checkout step. Then our Nix installer action installs Determinate Nix for you, so you don't have to do any configuration or anything. And this is a next generation installer that we wrote in Rust and that we thoroughly test in a wide variety of environments. It's also super fast. Then FlakeHub Cache Action finally enters the picture, and it's just a one-liner. And as I said, it configures everything, sets up automatic caching of everything you build. So in the next step, that I'm just calling build and cache package here, you see a Nix build command. And this is, assuming that you have a default package output in your Flake. So when you run this, you're using FlakeHub Cache. And during the realization process, if any dependencies are already in the cache, they get fetched. If not, they get built and automatically sent up to the cache. Now, again, anything you build here uses the cache in this way, either fetching or building and pushing. So if you Nix build a development environment or an OCI image or NixOS configuration or anything else that's buildable with Nix, it's just going to happen automatically for you. And so now, if I'm using Nix on my laptop and I'm in the same org as this repo, and let's say I'm also on Linux, like the Ubuntu builder here in this action, then anything that gets built in this workflow is now cached for me as well. So my Nix now knows about this cache as well and knows when it can substitute instead. So in this example, whatever this package is, maybe a CLI tool or a web server or something, I don't have to build this myself anymore. If I need this package in any dependency tree of anything I build, it's just quietly there, period. And it's quietly there for your future CI runs, and it's quietly there if you run NixOS rebuild and then running NixOS system. It's quietly there for your coworkers on their workstations, and it all just works. So FlakeHub Cache Action has, like I said, has this great property where it automatically caches things for you if you build them in CI. But the thing is, you have to actually remember to build things in your workflow. And if you have a scenario where you need to build lots of different things across lots of different systems, like let's say macOS, Linux, both ARM and AMD, and the like, it can get a little tricky. You can use things like build matrices and actions in on other platforms, but we recommend using an action that we built called Determinate Systems /CI. Very, very simple naming there. And what this action does is it automatically builds and thus caches all of your buildable Flake outputs with Nix. And it does it across all the systems that the outputs are for. So if your Flake has, for example, 10 different packages that all need to be built on 4 different systems or 6 different systems, whatever, this action will automatically generate the matrix build for all these different systems. And as you can see from the configuration snippet, it's just a few lines of straightforward YAML to get it to work. Now, this is definitely one of those auto magical solutions that may not work for every use case. It's not super duper configurable, but for straightforward use cases where you just want to get it all in there, it's definitely worth considering. And again, it works, for packages, for caching development environments, NixOS systems, OCI images, whatever it is that you're building. Okay, so you pushed all kinds of fun stuff into FlakeHub Cache for your Flake, and now you want to actually use it. You want to actually fetch stuff as part of your realization processes. And I mean, it's kind of a boring slide. There's really not much else to say here. Step 1 is to just use Nix. You've installed Determinate Nix, you've logged into FlakeHub, and now, I mean, there really isn't a step 2. Now, when you're building things with Nix, development environments, NixOS systems, whatever, you'll start to see this in your log. So you'll start to see copying path, Nix store, whatever, from cache.flakehub.com. And that's really it. And this is the evidence, kind of the only evidence you ever have that you're using FlakeHub Cache. So you start to see this log, and presumably more and more over time as you expand your usage. And this will happen on your workstation. You'll also see it in CI. You'll see it on your embedded devices or whatever else you're using Nix on. And this is the kind of fairy dust that I was referring to before. Determinate Nix and FlakeHub, they just quietly do their thing in the background, and everything is just faster and better, and you barely notice it until you have to live without it. So I want to quickly point out some things that you don't have to do when using FlakeHub Cache, just to kind of reinforce the point. First, you don't have to edit any configuration files ever. You don't need to touch a nix.conf file. You don't need to touch a netrc file. Everything just works. We think of it as being something like Tailscale, but for Nix. So, you do some basic setup and it just works and you forget about it. And you only notice it when you change jobs and you have to talk your new company into using it. Like we use Tailscale internally, and I can't remember ever thinking about it. I've never touched a configuration. I just logged in one day, and now 2.5 years later, I've been using it every day at work. And we think of FlakeHub as being very much like that. Second, you don't have to copy any keys or secrets into CI. You certainly don't have to rotate or regenerate any keys or secrets. FlakeHub Cache uses the JSON web tokens provided by GitHub and other platforms. And if you trust the authentication mechanisms of those platforms that we provide, then you're all set. And one last thing, of course, is that that doesn't happen is you never accidentally push something to the cache. And as we covered, only trusted platforms get to do that. Now, I wanted this webinar to be focused on FlakeHub Cache, but I think it's important to mention how it fits in with the rest of what the FlakeHub platform offers. So another major feature of FlakeHub is private flakes. And these are flakes that are available only to people inside your organization. And when I say available, I mean that you can run Nix Flake Show against them. You can add them as inputs to other flakes and so on. Now, private flakes use the exact same authentication model as FlakeHub Cache. And in general, FlakeHub Cache and private flakes work seamlessly together. So if you have a flake that you want to restrict to your organization for security or whatever reasons, the cache for that flake also only exists for the people in your organization. So FlakeHub Cache is always private. There are no public caches. And private flakes just kind of go one extra step and restrict the flake outputs to Nix users in your org. And that's really it. Another feature of the FlakeHub platform is what we call resolved store paths. So this is a feature that enables you to apply a NixOS configuration system with a single command with FH, the CLI for FlakeHub. And it also works for Home Manager and Nix Darwin on developer machines as well. So an example command would be FH apply plus this flake reference. So my org, my NixOS config flake dash star as a kind of just to get the latest flake reference, flake release, sorry. And what this does is if this system is authenticated with FlakeHub Cache and the NixOS configuration for it has been built in CI and pushed to the cache, it pulls the closure directly from the cache without even needing to evaluate the store path for that configuration. Now, evaluating store paths can be an expensive operation, sometimes so expensive that it can crash a resource-constrained device. And so what we do is we actually calculate and persist the store path in FlakeHub. So when you run this command, you just fetch directly. And this unlocks some really fun deployment scenarios that I'm going to talk about a bunch in the next webinar. If you're running Nix on NixOS on AWS, and we also support federated authentication for this. So if you run Determinate NixD log in AWS, we use AWS as security token service or STS to authenticate your instance and determine which org it's associated with. And then you can just pull from FlakeHub Cache directly. If this use case sounds appealing to you, we publish our own AMIs or Amazon Machine Images that come with Determinate Nix and installed, as well as FH FlakeHub CLI. So in general, FlakeHub Cache is not just a feature that we offer, but it's really a vital part of the platform. And it's part of an end-to-end experience of using Nix from installation all the way from installing Nix on workstations and wherever, all the way up to running production systems that you built with Nix. So we've talked about the current status of FlakeHub Cache, but you also may be curious what we're considering for it. So we're actively soliciting feedback from customers and users and the Nix community more broadly. So please feel free to weigh in. One thing that we're thinking about is fine-grained auth tokens. So at the moment, FlakeHub Cache only supports what we call coarse-grained tokens that grant cache access at the organizational level. So if you're a member of an organization, you generate a token in the FlakeHub UI for your workstation, you have access to all of your organization's cache slices. What we're considering is enabling organization admins to choose which flakes specific users have access to. So if your org has a username leetcode1337, an admin could provide them with cache access to the flake called web service, but not to the flake called top secret. An analogous feature would be what we call device tokens. So these are auth tokens that you can generate for specific devices, and these tokens grant access only to some specific published flake, or you can even restrict access to a specific flake output. So if you have a device running NixOS, for example, you can generate an auth token for this device, and that would allow it to pull only its own NixOS configuration from the cache and nothing else. I think that both of these features would constitute a pretty natural evolution in FlakeHub's access control model, but they would also add a fair amount of UI surface area to the platform. And so, we want to gauge interest and get some feedback and maybe even some beta testers before we dive fully into it. So if these sound like valuable features to you, if you have a use case for these things, please do reach out to reach out to us at sales@determinate.systems and let us know. And that's it. Thank you so much for coming. If you have any questions or any further curiosity about anything, please do stick around for the question and answer session. At any time, day and night, whenever, feel free to reach out to us at hello@determinate.systems. Come talk to us on Discord at determinate.systems/Discord. And if you're game for another webinar, like I said, we're going to be doing another one in a few weeks on using Determinate Nix and FlakeHub as part of a variety of interesting deployment scenarios. So yeah, thanks again, everybody. Thanks for coming out.
Right on. Thank you for that, Luke. I love, how you mentioned, like, it's one of those things where it works so well, you almost just don't know until it's gone or not there. Okay, we've got some questions. So I'm going to start asking them. Luke, you ready to do rapid fire answers?
Yeah, to the best of my ability, yes.
Yeah. All right. So we have a number around security. I might try to answer the first one and then let you add anything there. So the first question says, there was a GitHub action recently that was stealing secrets from the build environment. Is FlakeHub Cache vulnerable to that same kind of thing? So the one thing that I know is that we don't use secrets, right? We use JWTs provided by GitHub Actions runtime. And so I believe what that means is that if an attacker manages to mint a malicious JWT, it's going to expire automatically, and the attacker is then going to have very minimal access. Can you comment on that? Am I correct in that answer? Do you have anything else you want to add to it?
Well, I'm wondering if the question is, yes, I think that is true, that that an attacker could somehow generate a malicious JWT and get access, and that would, as far as I know, yeah, that's a great question. I haven't thought about much. I'm wondering though if the question is about like other secrets, so not necessarily authentication for FlakeHub Cache itself, but rather accidentally pushing, like, let's say, like API keys into the cache. Currently, we do not have any built-in mechanisms to keep you from doing that. So, in general, we advise not using static secrets at all. If you can get away with it, we recommend using, using platform-specific secret engines, or using vaults, or rotating tokens and things like that. If you do have to use static secrets, though, no, we don't currently have a way to prevent you from pushing them into your own cache.
Yeah, at least not for things outside of FlakeHub. But for FlakeHub, the method being JWTs provides a lot of protection there. So another question on security. How could somebody evaluate whether the upstream cache, cache.nixos.org, is secure enough for their use case versus the need to use something like FlakeHub that adds like an extra layer of security? Do you have any thoughts or recommendations there?
Yeah, I think that in the last webinar, we made some statements about cache.nixos.org, and I think that some of the public reaction got me thinking that I don't currently have a great answer for that. In general, the upstream cache is quite good. There are mechanisms in place, so it also follows a trusted builder model where only Hydra is allowed to push to it, and so Hydra is this advanced CI system for Nix packages. In general, we think that for environments with stronger compliance requirements, we recommend disabling it and just rebuilding your own artifacts internally and pushing them to FlakeHub Cache, and keeping everything nice and private, of course. I don't have like a knockdown, drag out answer for why you should do that. But we're going to do some more research, because I know that people on our team have a much more fine-grained sense of how these mechanisms work. So we're going to be publishing a technical blog post on FlakeHub Cache pretty soon here, and I think that that's something that I'm going to cover in there. So I don't want to give you like a half-assed answer now. I prefer for us to think about it internally and provide something much more fleshed out.
Yeah. Yeah. And I think part of it also just comes back to the nature of what you're doing, right? Like for a lot of folks, you're using packages that are in, Nix packages, you're using, the upstream cache for a bunch of stuff. But if you are doing a lot of proprietary development and you have a lot of your own, your own stuff that you want to keep private, now you kind of are pushed in that, direction of having a solution that just natively does offer you that security. Um, and then I think the other thing is like, you mentioned this, if you need any kind of compliance, you need to meet any kind of compliance standards. It's a really easy way to be able to check those boxes and a lot of those common compliance frameworks. Okay, I got a question. This is a really interesting question, and I'm trying to break it down so it's not too long for you, Luke. It's something I know Graham has been thinking about and, ideating on, but it's not next up on our roadmap, but it is something we may look into. And that is, let me just read the question. So, is it possible to put a local proxy in front of FlakeHub Cache? So this would be something like a NAS in an office or a lab, and do so in a way that you can retain FlakeHub's authentication and security features, but
Mm.
deal with like really, really large, like, containers or images that you might have stored locally. So the idea would be like, helping out in environments with these really large downloads. Is that anything you've thought about, Luke? I know it's an interesting concept, and like I said, I know Graham's talked about it, but I'm curious to hear. Do you have a take on that?
No, not really. I That's not something I've tried or thought much about, but I think it is. But it is an interesting question because yeah, it is one thing to be using Nix to be using FlakeHub Cache for to fetch 500K there and 1.2 megabytes here and 37 bytes there, and it's something else entirely to be caching entire like OCI images, of course, that sometimes can get into the gigabytes, if not close to the terabytes. I'm sure if it is for some job application, not sorry, that can get into the high hundreds of megabytes and into the gigabytes for, especially if you're running like a Java service or something. That's quite easy to imagine. So no, I don't have a great answer for that. I haven't thought on it, but that's something that we'd love to chat about that in Discord. Is that something that the authentication story in particular is one that I can't quite think my way around, but it is intriguing.
Yeah, it is. It's a really interesting question. At first, I was like, well, I don't understand how that would make sense. But then the more I thought about it, I was like, okay, actually, I'm starting to understand where, like you want the benefits of FlakeHub specifically around the authentication and security, but you also have, a lot of locally stored stuff. So it's not that you're against the cloud, but it's at a certain point, do you keep moving these things around if you have them in your lab? Yeah, for the person that asked the question, I have their name here. We might follow up and get some thoughts or ideas on that because I think
Sure, sure.
it is something like that kind of goes in the direction of almost more like a hybrid or like managed. It's like maybe not quite all the way to local on-prem, but there's some interesting ideas there. Here's another one that'll be easier for us to answer more directly, and that is like, what if I don't use GitHub Actions? Can I still use FlakeHub Cache? Like, what if I don't use GitHub at all?
Yeah, so we do have GitLab support in experimental status at the moment. We have I've certainly gotten it to work. I haven't checked back in on that in a while, but yeah. So I'm sure at some point in the near future we're going to revisit GitLab support. I can grab a couple. Let me see if I can pull up a link here. I haven't logged into GitLab for a while. This might take a second. This is another thing that we can we can chat about a bit more in on Discord if you like. I can send you some links to some of our GitLab. What do they call them? Not actions, but like CI extensions. Yeah, I think CI extensions. We did create a couple of those that seem to work. Like well enough. But that hasn't been a huge priority for us. If there are other platforms that you'd like to see supported, we're all ears. Of course, as a small company, we need to prioritize and use our time wisely in terms of interest and such. But we have we did build FlakeHub in such a way that adding new platforms should generally be, I don't want to say seamless, but but adding new platforms is very much, goes with the grain of how we built FlakeHub. So as long as they're issuing JSON web tokens, as long as they have an authentication model that we deem sufficiently, ergonomic, trustworthy, granular, et cetera, then it shouldn't be a huge issue in general.
Yeah, and I can kind of follow up, and this will be the last question looking at time. But to add on to what you just said there at the end, like we strive to support platforms that do federated auth with JWTs. So while we started out with GitHub Actions and then we added the experimental support for GitLab, that is very stable actually. The roadmap has us moving to a model where anyone that can issue federated auth with JWTs is something that we will support, and we are actively prototyping with two other CI tools right now. So stay tuned for answers on expanded support. So instead of it just being we're going to support these X number of CI tools, the plan is to be if you can issue a JWT for federated auth, then you can use it with FlakeHub. So, but looking at time, we scheduled these for 45 minutes and we are at time. So I am going to wrap this up. Sorry, one other question just came in and it could be interesting. So let me ask it. Is it possible to give access to my FlakeHub cache to all products that I build? I'm building a small home server for self-hosted Nextcloud that runs with NixOS in the backend, and it's built from a Flake. I want to configure it so it fetches and updates automatically, so the users of my product can benefit from my builds and not build locally. What do you have to say about that, Luke? And then we'll wrap up.
Well, a short answer is no. We don't. FlakeHub Cache does not have any kind of public caching model. So if these users that you're referring to, if they themselves are Nix users, and Nix is the way that they would be pulling these dependencies, then at the moment, no, we don't have the story directly for that. If, on the other hand, you're distributing things as zip files or tarballs or whatever, then I would recommend building those things with Nix and then pushing them to like an S3 bucket or something like that, and enabling that form of download. GitHub, of course, has they have their artifact storage mechanisms that provide you a nice stable URL for fetching things of that sort. But yeah, the short answer is that if you want to distribute Nix things to users, especially to like an indefinite set of users out there in the world, that we do not currently provide a way to do that with Nix.
Cool. Yeah, this is another interesting use case that we can always follow up on and see what we can do to make that an easy yes, because I think there are some ways. So, okay. Sorry for that last minute thing. I just like to try to get in as many unique and varied questions as I can. So let's wrap it up. So a quick reminder, this was recorded, so we will be sending that out. If you're interested in learning more about FlakeHub, just go to flakehub.com. We have the coupon code. It's up and running, and that's going to give you, is that a month free? Is that right, Luke?
A month free, yes. Yeah, that's correct.
For anyone that was on the live webinar, if you're watching this as a recording and you want to try it out and want to have a coupon code, send us an email, hello@ or sales@determinate.systems, and we'll get that to you. And if there's anything we can do to help you design your caching strategy for your organization, let us know. We're happy to help out. And even if it doesn't require using FlakeHub, that's okay. We want to see more and more Nix use across the world, across the ecosystem, with or without our stuff. So we are happy to help out. Just send us an email, hello@determinate.systems. Okay, that's all for us for now. Thank you so much, everyone, for joining. Thank you for those that are watching on the recording, and we'll see you at the next one. Bye-bye.